Hi everyone, Uchenna McPhee's here again from Nutshell Concepts, and this is part two of our project. Second video, the first video, we designed our standalone system. I'll leave a link and if you haven't seen it, so you can see it. We designed our standalone system, and we concluded that we are going to go ahead and order the components we need, what we have, and they're here. And I shall introduce them to you one by one. But in the meantime, let's look at where we left off. Right? Let's look at where we left off the last time. All right? In the last video. In the last video, we came up with this design, right? And then we said we're going to order a 12 volt 75 watts solar panel, a charge control about 6 amp or 6 amp steady charge discharge, battery bank 12 volts and 23.5 amp hours, an inverter about 120 to 200 watts. We determined that our wire gauge will be about 10 number 10s and number 12s, and fuses the range between 7 and 10 amps. And a quick scan of what we got up here in this box right here. We have a charge controller and our inverter. Right beneath that is the battery, deep cycle. In this corner right here are the loads, and like I said, I'll go through those with you. The components, the parts that we're gonna use to build the system, terminal blocks, terminal strips, connectors, fuses, heat shrink, and over on this side is our solar panel. We would also, I'll go through each one by one. All right. Okay, so let's start with the load. We determined that we're gonna get a lamp, a laptop, and a cell phone. Here's a lamp, and we're gonna insert a 13 watt CFL in that. If I can just see where that says 13 watts, should be there somewhere. Oh, here it is. Okay, if you look, you see that 13 watts. That will go in here, screwed in, and when we're ready, plug it in. That'll be one of our loads. The other load we have is a cell phone, right? And of course, the adapter is where you are going to be able to see the consumption, the wattage that this draws. It's probably hard to see. It's very tiny in this iPhone, but if you have one at home, you can look at it. It's pretty much what we said. It's about, it has an output of 5 volts and 1 amp, and then we have a laptop as a surface, and also very tiny, hard to see, but if you can read the fine prints over there, you see somewhere there it tells you that it's going to be 12 volts and 2.58 amps, like we talked about. So these are the load, or this is the load that we plan to power up using our standalone system, right? So that takes care of that. And then let's look at this other devices here. So right here I have a charge controller, right? This is a charge controller. Wires coming out. It's a very basic kind. Doesn't do much except just regulate the charge going of a battery. We had determined earlier that our charge controller should have a 12 volts, run on a 12 volts with a 6 amp. And you can see here that we're looking at a 12 volt and SIPs rated 6 amps. So we go with that guy. Let's look at our, however, one thing that we did mention is that our fuses to this circuit was going to be 10 amp fuse. To the battery side will be 7 amp fuse. But the charge controller comes with its manual, and it's always a good idea, no matter what you think you know, to read a manual, no matter how familiar you may think you are with a system. It's always a good idea to read your manual. And this manual actually tells us that our fuse rating, let me see if I can find that somewhere here. Hold on. Tells us about our fuse rating. It says our fuse rating for SK12 should be for SK6 should be 8 amps, right? So we have 10 amps, so we should be good if we ever wanted to use that, right? No minimum of 8 amps, and we've got SK6, so that is good. For our charge controller, for our inverter, we determined that we're gonna get an inverter. We determined that we're gonna get 120 and between 120 and 200 watt inverter. What we got here is basically one that has an AC output of 115. This should do it. It's pretty much has a 12.5 volt DC, which is what we want, and 115 volts AC. Comes out to about, we said this guy is about 350 watts. We determined that we wanted to get about between 120 and 200 watts. This is actually at this rate, right? At the rate of 350 watts is good enough. We can work with this. All right. Okay, and then the next is our battery. We got a dip cycle battery. We determined that it was going to be a 12 volt or 23.5 amp hour deep cycle. This is a deep cycle, 12 volts or 26 amp hours. So this is good enough. This will work. Slightly bigger. Exactly. I mean, this is the size we were going to get anyways, or else we were going to get something smaller or something a little bigger. We were not going to find a 23.5 amp hour. So 26 amp hour, perfect. All right. Then what we have next is the other stuff, like our wire. We got a number 10 wire here, the south wire. This is a THHN. And then we have number 12 outdoor wire. All right, we're going to use that as well. We have a fuse. Now this is a fuse holder. I found this guy. I haven't seen this kind before, but this is actually pretty good. You just have to open it, and then you're gonna pop. You just pop the fuse in there. Those kind of fuse that go in there. These is DC fuse. So, but this is also rated at. It has a rating for about 30 amps. So up to 30. It says here up to 32 volts DC. So this is perfect. We can pop that in there and have our fuse wired. We got connectors, like I said, terminal strips if we need that. And then we also have, what else do we have here that we need? So basically we've looked at a battery, a charge controller, so we're going to look at our panel next. We looked at an inverter, we looked at our loads and our fuse and our wires. So we're pretty good. Now let's look at our solar panel, right? So the solar panel we got, it's pretty much eventually became an 80 watt. Here's the label telling us what we have, right? So it's the motor, it's rated a maximum power of 80 watts. Yeah, I know we talked about the 75 watts, but 80 watts, pretty, even better. It has a current, maximum current of 4.44 amps, maximum voltage about 18 volts, and then it has a short circuit current of 4.85 amps and open circuit voltage of about 22.3 volts. So, but it is what this would definitely work for what we're looking to do. It is a 12 volt panel, in spite of the labels you see there. These are for maximum and for the maximum production and short circuits and all of that. But we did use this information. If you look at our video part, in the first part, we did use these pieces of information to do our calculation anyways. All right. So what we could do right now is check the voltage just to be sure that this guy works. And if we open this guy here, I can get a meter, and we can pretty much see what, measure the voltage here, right? Okay, so we have the panel, the cell, the side that has the cells that actually capture the radiation facing the other way. So there's basically no radiation being captured, no light being captured right now. So we can just take a voltage and see what we get, right? So if we set that to, and then positive, negative, right? And over there, we can see we're getting basically nothing, right? Just shorting between 0. Basically a neighborhood of 0.1 volts, right? But let us see what happens if we face the light with this and see if we will get a better voltage or different voltage if this turns around facing some kind of light. So with this facing some kind of light, we can do that again, and our voltage, it's much better. Irregular, but still much better. And I should change that mode to DC. And yeah, it's basically with light, it's giving us, about 10 point, 10 volts, 11 volts. Now let's look at that without light. No light, see what we get. Without light, you can see it's about 5 volts, right? So that's how solar works. It doesn't actually have to be sunlight. It's photon. Any kind of light will do the trick. But you can imagine we get 10 volts now. We're aiming for 18, between 12 and 18. When we go outside with this and have it inclined or tilted at the right angle, we should be able to get anywhere in upwards of 12 volts that we need, 18, and we'll be all right. All right, guys. And at this point, we'll be ready to build. Okay, join me in the next video, and then we actually start putting all this together and power it up or energize it. All right.